So the last time that we met, we'd been doing a weight saving exercise on the various 3D printed parts. As you may have recalled, that's bad English. As you may recall, if you even saw it, basically I took took away a load of material off of the duct, and we got the weight down considerably, but not quite as much as I really wanted. But anyway, that was that. Then it suddenly occurred to me, or it didn't really occur to me to be honest, but I had originally wanted to print all of these 3D parts out of ABS, and the reason why I chose PLA was because I haven't really done any of my own printing yet, and PLA is a lot easier to print than ABS. However, when I looked into ABS, it turns out that it's significantly less dense than PLA, somewhere around about 20% in fact. So I did a similar exercise where I simulated what the density of an ABS part would be with 40% infill and some solid perimeters and tops and bottoms, and it turns out that it actually is quite a significant weight saving. So if we convert this to my new ABS material, and as you can see it's now a nice fetching purple colour. Actually, let's undo that a sec. Let's remind ourselves of what the mass is. What the mass is when it was in my PLA material. It was 360-ish grams. If I now convert that to the ABS material, and it's otherwise exactly the same, and have a look at this, it's gone down to 298. So we've saved over 60 grams purely by changing the material. So that is the way forward. What I then did was to start carrying out weight saving exercises on the other 3D printed parts. So here is the sort of engine support and tank support structure. I've taken away a whole bunch of the material. Really, this part here is just supporting the tank and just stopping the engine from moving around about the place. I've left the front fairly heavy because that's where the actual engine's going to mount to, but I think that will be fine. And the weight of that is now down to 82 grams. I then did a similar exercise on the bottom support structure for the engine. As you can see, I've cut away a load of the material and changed it to ABS, and this is now coming in at 113 grams. So this has given us a considerable weight saving. If we then go back to the full assembly, as you can see, now everything is in this purple colour, which means I've converted all of the 3D printed parts to that ABS material, which has saved the weight quite a bit, to be honest, with all of these various bits and pieces. I haven't really done much weight saving on any other parts. I mean, I've added a little bit more material removal on the centre support structure. The rudders really, I couldn't remove much more material. I've taken a bit away, I've scooped out something around the edges, but that's about all I could do there. But I have added some weight. As you can see, the floats now have these support structures inside them. Now, these aren't really needed for strength so much in the final finished item, because once this is all glued together and it's got a top on it, I think it will be plenty strong enough. So these are really there to aid construction, because as you can see down the length of some of this ply, it needs to curve. So essentially what I'll be doing is screwing, the ply to this at one end, and then down here and down here. I'll probably dampen down the ply to make it a bit more flexible. And then once it's dried out, hopefully it will retain that shape. And if that's the case, and I'm quite confident that it doesn't need them, I can then remove these at that point. They also, at the moment at least, provide some way to bolt the floats to the hull centre. And as you can see, I've got some bolt holes here where we will bolt through, and it will bolt into the ABS parts here and at various points along there. Again, the mechanical fixing's probably only there mostly for the construction, because once it's all glued and sealed together, I think that will provide a strong enough bond. But yeah, a few securing fasteners won't go amiss. So what else have I done? Well, I have sort of finished off, and let's isolate the nose for a bit. Oops, not that button. Isolate the nose. And basically what I've done is I've incorporated into it a little sort of profile that pokes out, and will just better make sure that the batteries are held in place and don't jump about the place. I've also put some countersunk screws into the front so it can secure to the rest of the hull. And I think really from, you know, all the components are kind of there. So then what I started looking at, and if we add the top pieces back to the hull, so that's that, and that's that. Close this down again. So what we should be seeing here is the final weight minus a minor amount for the radio receiver, which I haven't included yet because I don't have and I don't know the size and shape of. But in any case, they're fairly light, probably around 10-15 grams, and it's going to be easy to mount, so no biggie there. We probably also need to allow weight for some of the fastenings, but again, that's not going to total up to a great deal. We've got fuel lines and some other bits and pieces, but we're talking about fairly trivial weights. So what we've got here is more or less the entire weight of the boat. What I should mention first is that I went through and spent some time making sure that the weight of each component is correct. We know that the weight of the 3D printed materials is about right. I've checked the weight of these aluminium tubes, that is right. I have filled the tank, as you can see it's now sort of a orangey colour, not all the way up to the top, but yeah, full. And I've checked it against the actual weight because I've measured this full tank in reality, so that now weighs exactly the same, give or take, as the real tank does full of fuel. I've done the same exercise for the engine and the prop and everything else, so everything is accurate in terms of its density. So if we look at the mass properties of this entire structure, we can see that our boat is coming in at 2,799.51 grams. So we'll call that 2,800 or 2.8 kilos. So yeah, from that I've been able to return and look at the buoyancy calculations. And if you remember where we have this whole design as it stood, and I have made some changes to it, but where it stood before, it provided us with something around about 2.4 million cubic millimeters of displaced volume. And as we're using a very round number for the mass of water, we know that essentially, if we look at these mass properties again, where we get, let's say, 2,800 grams, that translates into 2.8 million cubic millimeters of displaced volume that we need in order for it to float. And we were only around 2.4, so although it might not entirely sink, it would be lower in the water than I wanted. So if I open up the hull, and yeah, so this is where it stands right now. Let's go back in time a little bit on the hull, because we actually want this to all be solids rather than hollow. We'll take it back to here. And let's have a look at the sketch for the center hull, because this is where I have made the changes. If you remember, I think we were down at about 52 or 54 on this dimension here. So that is the depth, if you like, from the very top surface of the center hull to the very bottom of it. So basically what I've done is I've increased that depth. So we've got more of the center hull below the waterline. I have also increased this dimension here, which is the distance where the hull is flat before it starts curving up. which gives us again more of the hole below the waterline. So let's come out of that for a second. And what we shall do is we shall perform the same exercise we did a while ago, where we split these solid bodies into the parts that will be below the waterline. So let's show the waterline plane, and there it is there. That hasn't changed. All I've changed is the amount of the hole below that waterline. And if we split that all up into separate parts, so that we've got parts above and below, and yeah, intersect, not merge, yes. Select only the bodies which fall below the waterline, which is that one, and that one, I think. Yep. So those are the solid bodies which are below that waterline. Check the volume, and it's 2.9 million cubic millimeters, and we need 2.8. So this is actually slightly more buoyant than we need right now. However, that basically gives us another 100 grams that we can add to it. So if we add in the radio receiver and some fasteners, we'll probably be very, very close to 2.9 kilos, which means we will float more or less exactly on this line, if all my calculations are correct. And yeah, la-di-da. So let's close this down because we don't need it and we don't need to save it. So what we have is pretty much the final design of the boat. Now if I add its lids back on to make it even a little bit more complete. So there it is really. Here is our completed design. It's accurate in terms of all masses, sizes, densities, and according to all the calculations it will float in the right place. The angle of it in the water should be about right. We can adjust that with some ballast where needed. So yeah, I'm happy with that. I'm happy to start with the construction. However, that is going to have to be put on hold slightly because, as you will notice, quite a lot of this is made out of 3D printed parts, and I don't have a 3D printer yet. I do have pretty much all of the parts to build a 3D printer, so the little RC boat project is going to go on hold while I do the build a 3D printer project. So yeah, that's probably going to take me a week or so to get it up to the point where I can print these parts reliably. But then yeah, definitely we'll be back, be printing the parts, cutting the ply, putting it all together, and hopefully this boat will work, will chooch, as they say on Chum's channels. So yeah, looking forward to it. But now we're going to be focusing on a 3D printer for a while.